Today we are going to discuss about the polar coordinate. Okay, so in a plane we represent a point as x comma y, that is what usually we call it as in Cartesian coordinate. So that means, so this is x and this is y, this distance. Now, as we can see any point in the plane, if I take this, then it lies on a circle of the radius r. Now, this point is lying on this circle centered at the origin. Now, how do I distinguish between these points on these circles? It basically we can distinguish it, although all of them they have the same radius, they are lying on the same circle, but they are distinct depending on the angle they make with the x axis, that is theta. So, in a sense we can represent this x comma y as r and theta. So, this type of representation is called polar representation. So, this point has the polar coordinate r comma theta. So, as basic trigonometry will tell us that this x is equal to r cos theta and y is equal to r sin theta. Okay. So, every point in the plane we can represent it. For example, take the point in this polar coordinate (1) and pi by 4. Then in the Cartesian coordinate, this point 1 pi by 4 is going to look like. So, this is what is, if we take r is 1 cos pi by 4 and 1 into sin pi by 4, which we know that this is 1 by square root of 2 and 1 by square root of 2. Similarly, the point 2 pi by 3, this is going to be represented in the Cartesian coordinate (2 cos pi by 3 and 2 sin pi by 3, which is equal to 2 into 1 by 2 comma 2 into root 3 by 2, which is equal to 1 and root 3. This is the point 2 pi by 3 and the point 1 square root of 3, they are the same. This is in the Cartesian coordinate and this is in the, this chap is in the polar coordinate. There is a difference in the polar coordinate. Look like this. Suppose I have a circle of some radius r. Now, I look at this point theta. So, this is going to be theta. Now, I move. So, this angle is nothing but 2 pi plus theta. Then I am getting back in the same position of the circle after I travel another 2 pi theta. So, basically, if you will look at 1 by square root of 2, 1 by square root of 2, this in polar coordinate, in polar form, this we have seen that it is written that 1 and pi upon 4. Also, we can write this as 1 and 9 pi upon 4. Now, 1 pi upon 4 is same as 1 comma 9 pi by 4 in the polar coordinate. So, as a matter of fact, this we can write it as 1 pi by 4 plus 2 n pi, where n is an integer. After every 2 pi, I am going to hit the same point again. So, polar coordinate has many representation. So, what we want to take is that the representation from the 0 to 2 pi. Okay. So, once we have this basics of the polar coordinate, which as a matter of fact we have come across in our earlier stages, let us try to graph the function which are given in terms of the polar coordinate. So, now the equation in polar coordinates is given by r equal to f of theta, or more generally for some function f, r theta is equal to 0. Now, the graph of this equation is the graph of the function f, that is what we understood. Okay, so, for example, let us say see some very easy example, r is equal to 2. That means, it is all those points for which can be represented in the circle centered at 0 0 with the radius r. So, this is going to be the circle with radius r. So, this is what is the circle r equal to. Now, for example, theta equal to constant, theta let us say equal to 1, then what it is going to, all those points for which the angle is theta. So, the theta equal to 1 will be a much smaller kind of thing. This is theta equal to 1 degree angle. So, this is what is all those points which are lying with the theta equal to 1 degree. Now, let us take little more non-trivial case. R is equal to 2 cos theta. Okay, so, let us try to see what it is. So, when theta equal to 0, R is going to be 2. This is 2 0. Now, when theta is equal to pi by 6, okay, so theta equal to pi by 2, let us take theta equal to pi by 2, then this is 0 0, because cos pi by 2 is 0. So, r equal to 0. Okay. So, now theta equal to pi by 6, then r is going to be cos pi by 6 is root 3 by 2 into 2 is root 3. So, this is root 3 when theta equal to pi by 4, this is when theta equal to pi by 4, then this is 2 into 1 by root 2, which is equal to root 2. So, pi by 4 is this angle, and so I will go up to r is root 2 pi by 4. This is what is our representation. So, similarly, if theta is equal to pi by 3, then r is equal to 2 into half, which is equal to 1. So, pi by 3 is 60 degree. So, this is going to be 1 and pi by 3. So, basically what we are going to get is that now we can see that this increases, now this decreases and comes up to 0. And when theta is equal to, let us say, 3 pi by 4, then this is going to be minus of square root of 2. So, now when you come up to pi by 2, then this is going to give you back to this to 0. So, this is what is the circle. So, this looks like a circle. Now, try to see it in the Cartesian coordinate, how does it look like? So, now our x is going to be 2 cos theta into cos theta, which is equal to 2 cos square theta. Y is equal to 2 cos theta into sin theta. R sin theta is your y, which is now this I can write it as sin 2 theta. This is 1 plus cos 2 theta. So, now look at x minus of 1, that is cos 2 theta square plus sin 2 theta square y square, which is equal to cos square 2 theta plus sin square 2 theta, which is equal to 1. That means, this x r equal to 2 cos theta represents the circle with radius 1 0 centered at 1 0 and radius 1. This is what precisely is the circle. Now, one thing you can notice is that with as per the convention. So, if we are looking at pi, suppose this is theta is minus of theta, if I am looking at, suppose this is minus of theta. So, then this is going to be r cos minus of theta, and then this is r sin of minus of theta. This is what is the representation. So, this is r cos theta and minus of r sin theta, which is equal to x, and this is minus of y. So, minus theta is equal to x minus of y, that is what this is what is by the convention, this is minus of theta. Okay, let us do another interesting example, example 4, which is a very famous example. This is cardioid is what? Let us define r equal to 1 plus sin theta. Now, let us try to graph it. So, let us look at theta between 0 to 2 pi by 2. So, when theta is equal to 0, what we are going to get? We are going to get this is as 1, theta is 0. Now, when theta is equal to, then sin theta is going to be an increasing function from 0 to pi by 2. So, therefore, this r is going to be an increasing function on from 0 to pi by 2. And at pi by 2, this is going to be a this is going to take the value of 2. So, essentially, so this will look like something like this. Now, you look at from pi by 2, r is going to be a decreasing function from pi by 2 to pi, and pi by 2 it is 2, and at pi 1 plus sin theta. So, sin pi is going to be 0. So, this is going to be a decreasing function on this from 2 to. So, r decreases from 2 to 1. This is up to this. Now, you look at pi less than theta lesser equal to 3 pi by 2. Now, in this region also r decreases because sin theta is going to decrease, right, pi, and this is going to decrease up to 3 pi by 2, then it is going to increase. So, on this definitely r decreases from 1 to 0. So, this what we are going to get. Now, in this region where 3 pi by 2 is less than theta is less than 2 pi. Now, in this region it is increasing. So, now increasing means, so this is going to sin theta is increasing from minus 1 to 0. Therefore, this r is going to increases from 0 to 1. This is what is the curve of the cardioid r equal to 1 plus sin theta. Now, next example, this is example 5. So, let us consider the function r equal to cos 2 theta. Let us try to sketch the graph of this. So, now first try to look at when 0 is less than or equal to theta and less than pi by 4, because 2 theta I want to move. So, now in this what is happening, if theta is equal to 0, r is going to be equal to 1. When theta equal to pi by 4, r is going to be cos pi by 2, which is 0. So, essentially this will come something like this. Now, if I write pi by 4 pi by 2, then at pi by 2 this is going to be cos of pi, which is negative 1. So, this is going to be like this. Then next let us look at pi by 2 to this is 2 pi by 4, 3 pi by 4. So, minus 1 at 3 pi by 4, this is going to be 0. So, we will do like this. Now, some 3 pi by 4 to pi. So, this is going to look like this. Now, again this is going to rotate. So, basically now I have the curve. So, this is how looks like a 4 petals of a flower. So, this is a beautiful curve. Now, once we can play around and sketch some of the graph of the curve in the polar coordinate, and once we have that, then we would like to ask ourselves that how we are going to use our calculus to determine the length of the curve, the slope, area under the curve. So, application of differential calculus and integral calculus in the polar coordinate. So, towards this, so let us first then try to find out the slope, that is the first and foremost thing for us to do. So, let us in the polar coordinate, what we know is that we know that x equal to r cos theta and y is equal to r sin theta. So, given a curve, we would like to find what is the dy by dx. So, this is essentially a parametric representation, you can think of it. So, now when I am writing dy by dx, this what we have seen is that dy by d theta by dx by d theta. So, which is equal to dy by d theta is equal to, you remember that r is a function of theta. Therefore, if I take the differentiation, this is the product rule I am going to apply. So, this is dr by d theta, then this is sin theta and plus r sin theta derivative is cos theta divided by dr by d theta at cos theta. Now, cos theta derivative is negative sin theta. So, this is r sin theta. So, this is what is our formula for dy by dx. Now, if we are looking at the tangent at the pole, then r is equal to 0, and if dr by, so tangent at the pole r is equal to 0. If dr by d theta is not equal to 0, then what we have seen is that dy by dx, this is nothing but dr by d theta gets cancelled, this term is 0. So, we get tan theta. So, this is the usual thing. So, now let us find out the tangent for a particular case. So, we have a beautiful curve cardioid. So, that is what we have seen is that just now we have sketched the curve. This is what is the cardioid. So, now we want to find dy by dx. Therefore, first let us let's call dy by dx. What we know is that dr by d theta. So, that is going to be cos theta into sin theta plus 1 plus sin theta into cos theta. This is what it is and divided by dx by d theta. What we have found is that dr by d theta, that is cos theta into cos theta and then minus of 1 plus sin theta into cos theta. Okay. So, this we can write it down. If I take cos theta common, then we have got 1 plus 2 sin theta. Then this divided by cos square theta minus, oh sorry, this we have again made a mistake. This is, yeah, this is cos theta, as you can see that r cos theta minus of r sin theta. So, this is sin theta. So, this is sin theta minus of sin square theta. So, this is simplifying it 1 plus 2 sin theta divided by cos square theta is 1 minus sin square theta. So, this is 1 minus 2 sin square theta minus of sin theta. So, this we can write it. Further simplifying it, what we get is that this is 1 minus sin square theta, and then this is minus of sin theta. If we take common, then this is 1 plus sin theta. So, this is equal to cos theta 1 plus 2 sin theta divided by 1 plus sin theta. If I take common here, it is 1 minus sin theta minus sin theta. So, 1 minus 2 sin theta. So, now if we want to find dy by dx the slope at the point pi by 3, let us say at the point pi by 3, then this is going to be cos pi by 3 into 1 plus 2 sin pi by 3 divided by 1 plus sin pi by 3 into 1 minus 2 sin pi by 3. Now, plug in the value. So, this is 1 half 1 plus root 3, because this is root 3 by 2. Now, this is 1 plus root 3 by 2 into 1 minus root 3. So, this is going to be half we get cancelled. So, 1 plus square root of 3, then divided by 2 plus root 3 into 1 minus of root 3. So, this is going to be equal to 2 minus 2 root 3 plus root 3 plus 2. So, this is 1 plus root, this if you simplify, this is going to be minus of 1. So, this is the slope at pi by 3 is equal to -1, and then we will continue finding out the slope for at various other point for this particular example in the next lecture. Thank you.